I don't know.
All right. All right, so I'm gonna draw a quick picture of the graph on this problem. So number 19. All right. And we've got, that's defined, so they have it labeled 0, 0. And they have that. That point is named 2, 1. And then we have another piece and it's doing something like this. And that point is named -2, 3. Okay, so we're going to say, okay, f of x is, we're going to come up with what this piecewise function is going to be defined as. So there's two pieces of it. There's this and there's this, and they're both lines. So we're looking for an equation of a line. So we'll tackle this one first. So I need two things to find an equation of a line. I need slope, need a point. And here I've got 2 points. And I just need to figure out the slope. So I'm going to figure out the slope of this line. I know it's going to be negatively sloped. Slope of this line, change y, -2, excuse me, not -2, that's the x value. Top. 3 minus 0. Bottom, I would go in the same order, -2 minus 0. So I get -3/2. Now, if you know the point, the line goes through 0, 0, which it does, contains that point, your equation of a line is going to be y equals mx because your y-intercept is 0. So in this case, this piece right here, finding equation would be -3/2 x. And then technically plus 0, that was your y-intercept. Now, when you put this piece in, you're going to say f of x equals then -3/2 x, and then you define over what values of x that this exists for. And it would be from where x is -2, and since that is a solid point, and that's a solid point, we'll put less than or equal to, which when I'm looking at the fields that you input, they have that for you already. So we'll say if x is going to be between -2 and 0. So there's that piece. And you actually have to put these in individually. So I'm going to go ahead and type mine in real quick. -3/2 x tab over, and then from -2 between -2 and 0 inclusive. That answer, we're good there. And then it's going to have you define the other part, which is right here. So we'll go through the same thing, find the slope really quick. I'll go 1 minus 0 for the difference of y's, and then we'll go 2 minus 0 for x's. So here we have a slope of 1/2. So again, since we contain 0, 0, it's just going to be y equals 1/2 x. So that's your other piece of this. Now, this one's going to be defined between 0, and you can't, I could not have two different x values. You have to define either this goes up less than 0 and this is less than or equal to 0, or vice versa. But they on the in the answer, it's defined for you. So this one is going to be, so if you input say 0, it's going to be this piece and not this one, because this is strict. And again, that one's provided. And then this is going to go up to 2 and include 2. And that's it. That should be all you need to do here. So I'm gonna type it in just to be sure they don't ask anything else.
So I understand where we got the -2 and the 0 and then the 0 and 2
Wait,
from.
I don't understand. Why are
What?
they in the order that they're in? Like, why do we list them like that?
Because it goes from left to right.
Yes, that is exactly it, left to right. So just like you would read left to right, you're going this direction. So here's x is -2, there's x is 0, and here's x is what, 2. So when you write out a piecewise function, it's going to go left to right from smaller to larger as you go down. So
Okay.
here to here. And again, the fields that you're entering in are right here. That's the only thing you're inputting. So
And it's just left.
they give you the inequalities.
Okay, that's what the part I was confused on.
Yeah, they're not, but like if you were defining it on your own, you would have to just either, as I said, this could still work if I got rid of this and put it here, but it has to be one, you can't have, you have to, every input that you have has to go to just one place. So you have to decide, is 0 going to be evaluated using this piece, or is 0 going to be evaluated using that piece? And they define it for you. Okay, get rid of that. And enter, and that's all they ask. So that's it. That's concludes the problem.
Okay. Then can we backtrack to number 12?
Sure. All right, number 12. Okay, so number 12 gives you a piecewise function. I'm going to go ahead and turn the page. And the piecewise function they give you is f of x equals, and there's 3 pieces to this. There's x, you're going to evaluate x as x squared if your input's negative. So if x is less than 0. If you input 0, you're going to get an output of 0. That's this part right here tells you. So that's just 1 point. And then any positive numbers that you want to put in, you will evaluate as 2x plus 2. Now, so that says here that the domain is all reals. Evaluated as x squared. If you put in a negative value, if you put in 0, you'll get 0 out. And if you put any positive number in, you'll evaluate here. Now, the first question is just evaluate f of -1. So that's where this comes into play. It tells you which piece you're going to evaluate it as. And since that is a negative input, then that says that's how we'll evaluate it. So in this case, it's 1. That would be your output. All right, then it asks you to evaluate on B, f of 0.
If it's less than 0, then you have to do x squared. So -1 squared.
Oh, okay.
Yep, this piece. So, didn't need that. Well, I can just make this a bit 0. So this says if you input 0, your output 0. So that's that. And then it asks you to evaluate f of 1. And since that's positively, your input is positive, it says then this tells you right here for any positive number, any input greater than 0, evaluate here with this piece. So that would be 2 times 1 plus 2, which is going to give me 4. So your output would be 4. And that's it. Good there?
Yeah.
All right. Another problem? Another question?
The domain. So, can we do 14?
Mm-hmm. Okay, so on 14, turn the page. We've got f of x is defined as 2x if you're any number other than 0. So basically, your domain is going to be all reals. If you put any number in other than 0, you'll evaluate it as 2x. If you put 0 in, this is the second piece. You put 0 in, the output's 3. And we're going to have 4 questions here. The first is find the domain. All right. And you're going to answer this in interval notation. And so when you're finding the domain of a piecewise function, it's right here. You just collect all this together, and in this case, it's going to be all reals. And how it's defined, it's saying if you put any number other than 0 in, you evaluate this piece. So that's all reals but 0. And then we got 0 here. So total, your domain is all reals, any real number. So like that first one we did, the domain there would actually be from -2 to 0, or excuse me, between -2 and 2, including that very first problem we did, the way it was defined. All right. B, it says locate any intercepts. Okay. So if we're going to find intercepts, that means we are going to find what? X-intercepts. And it's a function, so at most, we could have one y-intercept. So when you find an x-intercept, you let what? Y be what? 0. Now, and the way you're going to go about this is, in this particular case, all you're going to do is you only really have this piece to work with. That is, you're going to say 0 equals what? 2x. So what value of x gives me an output of 0? In this case, you just divide both sides by 2, and x is what? 0. So and that would mean your x-intercept is 0, 0. Now, anytime you get an x-intercept of 0, 0, you have actually found also your y-intercept. You find your y-intercept by letting x be 0. Now, but in this particular case, if you let x be 0, your output is what? 3. Now, so I want to type this in as I go. So let me get the domain in there. Negative infinity to infinity. Got it. Now, it says list the intercepts as ordered pairs. So it's always you got to be a little bit more careful with piecewise functions. Because in this particular case, when I go find x-intercepts, I let y be 0, solve for x, and I came up with 0, 0. But, which would mean, when I look at this, it just, the way this is defined, it says distinctly, if you let x be 0, you input here, and your output is 3. And so what this is telling me is that's not a point, actually. It has to be what? This can't be a point, simply because when I input 0, I get an output of what? 3. So there's only going to be one intercept. There are no x-intercepts with this graph. There's one y-intercept, and it's going to be 0, 3. Now, are we understand how I arrived at that?
Yeah.
Since x equals 0 on the y-intercept, whenever you tested it with 2x, and it says if x does not equal 0, then that means that wouldn't be an intercept.
Okay.
All right. So when you answer, it does tell you to put it in as an ordered pair. So I'm going to put 0, 3. Okay. So we found that we had one intercept. Okay, so the third question is graph the function. All right, so here was 0, 3, our intercept. Now we're going to graph this function. So the first thing I'm going to do is just do a quick hand sketch. Now this part's easy. It says if x is 0, output's 3, that would be the point, then 0, 3. This is a line, y equals 2x, and we would put it everywhere except at x equals 0. Now that you don't have to get too crazy with it, but anytime, I'm going to go over here kind of sidebar, I graph a line y equals mx so that the y-intercept is 0. That is, this line y equals some constant x. You know that line goes through 0, 0. And so since the slope here is 2, so I'll just kind of draw a line in here. Now I put an open circle right there at the origin. And then I just have something that looks like this. Just trying to sketch something that relatively looks like it has a slope of 2. You don't have to get too fancy with it. But you need that, you got to have that open circle here because, again, if I tried to close this circle up, then I would fail the vertical line test at that point. So it's got to look like that. And so looking at my options here, I've got 4 options. And C and D you can eliminate immediately as choices because they plot the point 30, not the point 03. So that gives you A and B, and it's real subtle. One line that, and that's A I'm looking at, that line has a slope of 1. So that's why it can't be it. It's got to be B. That's the only one that has a slope of 2. Are we good there?
Yeah, and then the y-intercept, that point's just by itself, like it's.
Yes, exactly. Just like that.
You have to go through.
So then the last question here is find the range. Now remember, the range is all the set of all your outputs. It's all the y coordinates. And right now we don't, but later on we'll be able to do a little bit algebraically finding range. Right now, all you can do is find range based on a graph. And so you would look at this, and this again is collect up all your y coordinates here. And it's going to have you answer in interval notation, but any line has a range of, except for a constant function, would have a range of all reals because you're going to capture every single real number as an output. The only one you wouldn't would be, again, a horizontal line. Your range is, trying to draw a horizontal line here, would just be one value. You know, like y equals 3, every y coordinate's 3. So your range would be one singular value of 3. But here I'm going to capture them all. Now, you look at this, though, you got to be a little bit careful. I've got this open hole. And so there is no way to actually get a output of 0. And based on the graph, I capture every single negative number up to here, but I can't get 0. But then I can capture every positive number. I actually get 3 twice. You know, this point right here, whatever the x coordinate is, its output is 3. And so it's all reals but 0. That's the only number I can't get as an output. So looking at your choices on your answers here, A says the range does not have any isolated values. It can be described by, and you would write one interval. Say it was all reals, you'd put -infinity to infinity. But we do have one value that it can't be, and we know that's 0. B says the range has at least one isolated value. It can be described as the union of the intervals and the set, and you would put in a number. The last one says the range consists exclusively of one or more isolated values. It can be described as, and in this case, it looks like we want A. And what you would type in here, because it wants interval notation, is, and I don't want, I'm not doing set builder. You would answer negative infinity up to what 0 and use a parenthesis, not including 0, unioned with the interval from 0 to infinity. This would be how you would describe all reals but 0 in interval notation. Set builder, it would be actually a little simpler because you could just say, but it doesn't ask for that. I'm just showing it as an example. X such that X is any number except it doesn't equal 0. All right, but it looks like we'll need A. And you'll have to type in, and it's kind of a pain. One day they'll actually put this in the template, toolbar template as well. But negative infinity up to 0. They do give you the union symbol on the toolbar, and then parenthesis 0, comma, to infinity. And that should do it. Okay, and that's the last question. Questions on that one?
No.
Good? Yeah. Okay, another question.
I'm good.
Good?
I think so.
Okay, so here's the deal then. Go ahead and